All right, welcome back to Mr. P Helps with Precal. This is Unit 4 topic number 1, lesson number 3, and we're going to be talking about unit vectors and do a bit of review of what we've done in the last two videos. So in this case, we have vector addition. So if we add this vector and then we put it tails to this vector, so that's going to be our resultant here. If we take this vector and then we do this to it, which is this one, heads to tails method, so that's putting the end, this point right here basically, then our resultant is going to be this. And then if we go this way first and then straight back this way, then this will be our resultant. I know that's not easy to see because they're parallel to each other. All right, so find the component form of vector v. All right, so we've talked about this before, but you can simply use the formula of magnitude times cosine of 82, and then magnitude times sine of 82. And that'll give you your vectors. So it's just a matter of using your calculator as I stall. Here we go. Thank you. 10 times cosine of 87 gives me about 0.523. And then 10 times sine of 87 is going to be 9.986. And that is going to be in the first quadrant. So first quadrant, that's to the right, and that's up, and that makes sense because it's an 82-degree angle. Same thing over here. So we have magnitude times cosine of 230 and magnitude times sine of 230. All right, so 6 times cosine of 230 gives me negative 3.857. I'm going 3 significant digits and rounding, and then 6 times sine of 230, and that gives me negative 4.596. Okay, so that's going to be the third quadrant. That makes sense because it's a 230-degree angle, and negative is in the third quadrant. All right, so what do you think about how can we find the angle and direction? Okay, so we've covered this as well. So the way to do this is use inverse tangent. So we have 3 and 5. So we want to find what this angle is. Well, first of all, I know it's in the first quadrant because we're dealing with a positive. So all I have to do is inverse tangent of y over x. Inverse tangent 5 divided by 3, which gives me 59 degrees, pretty close, 0.04 degrees. And that is, I don't need to do anything with it because it's in the first quadrant. So what if this is negative 2 and 7? All right. So I'm going to do inverse tangent of y over x. Inverse tangent of 7 divided by negative 2. And that gives me negative 74.05. But I know that's not right because it's in the wrong quadrant. So I need to add 180 to that. And that's going to give me 105.94 degrees. And that's in the second quadrant, so that makes sense. So I got an answer that was here, but that can't be what it is. It had to be in this quadrant. All right, so then negative 5, negative 3. All right, so I'm trying to find this angle in the third quadrant. So I'm going to do inverse tangent of y over x. So inverse tangent of negative 3 divided by negative 5, and that gives me 30.96 degrees. Now I know that's not right, so I need to add 180 to that, and which also is going to give me a positive answer because here, positive answer is also here. So it's actually 210.96 degrees. Okay, so on we go to unit vectors. So what is a unit vector? So what is the point of this? So if you have a vector on the coordinate system like this, let's say it's a magnitude of 6, and then you've got your angle here, it happens to be a 30-degree angle, then you can calculate where this point is going to end. But that's not where I want it to be. I want to scale it down to the unit circle. I want to know where would that point be if it was on the unit circle. Well, we do already know what that would be. Since it's a 30-degree angle, we would know that that point would be at square root of 3 over 2, comma 1/2, because that's what a 30-degree angle is. Now, I just chose that one out randomly. But what if it's like any of these? And I forgot to erase this, so I guess I should have just left this. So what I'm going to do is I'm going to find the magnitude of the vector that's given. And clearly you just saw what I was doing. So I'm going to use that formula of negative 2 squared plus 4 squared. Negative 2 squared is 4, and 4 squared is 16. So that becomes the square root of 20. Now that I know how I have a square root of 20 is my magnitude of this vector, I'm going to scale it down. So if the unit's vector, if the magnitude of vector u is square root of 20, I'm going to scale it down to 1 over square root of 20, which would be the reciprocal, in order to scale it down to this unit circle. Because I know that's the magnitude of this vector, so if I do the reciprocal of it, that's going to be equal to 1. Because anything times its reciprocal is always 1. Okay, so what I'm really going to do is 1 over square root of 20 times the vector negative 2 comma 4. So that's going to give me the vector of negative 2 over the square root of 20, comma 4 over the square root of 20. And there's your unit vector. Now, I can prove that this is the unit vector because if I do the magnitude of this, then I should get an answer of 1. So if I do, let's see, okay, that was not what I wanted to do. So if I do the square root of this, which would be negative 2 over square root of 20 squared plus 4 over square root of 20 squared. Okay, well, this simplifies down. Negative 2 squared is 4. Square root of 20 squared is just 20. And then over here, 4 squared is 16. And square root of 20 squared is just 20. And then add these two together, 4 plus 16 makes 20. So this becomes square root of 20 over 20, which becomes 1. This is 1, and then the square root of 1 is also 1. So I just took my unit vector, and I found the magnitude of it, and it happened to be a magnitude of 1, which proves that this is a unit vector. So I took that vector, and I shrunk it down to the unit circle to see where it would hit on it. All right, so I'm going to do the same thing for this question, and I'm going to first find what the magnitude is. So I'm going to do square root of 1 squared plus negative 1 squared. All right, so this would be pretty easy because this is 1 plus another 1 makes the square root of 2. So if the square root of 2 is the magnitude of this, which is like 1.2 something, I'm not really shrinking it down too much. Therefore, 1 over square root of 2 times our vector is going to give us our unit vector. So I'm going to solve this by multiplying by this scalar multiplication, and that's going to give me 1 over square root of 2, comma, negative 1 over square root of 2. All right, so there you go. There's my unit vector. And if I square this, that's going to give me 1 over 2, and I'm going to add that to squaring this gives you also 1 over 2, which equals 1. So the magnitude of our unit vector should always equal 1. All right, and last but not least, so writing this in this different form, so people like engineers, so I've been told because I'm just a teacher, they write their component form in using I and J. It really is no different. So 2, 3 can be written 2i and 3j. So in this case, this is really a vector of negative 1 comma 3. And if I want to find that magnitude, then I would just do negative 1 squared plus 3 squared, and that gives me 1 plus 9, so this becomes square root of 10. So the magnitude of vector u is square root of 10. All right, so what about vector k? So First thing I'm going to do is, well, I could change this. This is really the same thing as negative 5i plus 2j. So this and this are the exact same thing. And then find the magnitude of that. So that would be square root of negative 5 squared plus 2 squared, which becomes 25 plus 4. And then you've got square root of 29 is the magnitude. So k's magnitude is square root of 29. And I think that's it for this video. Thanks again for watching, and I look forward to future videos. Have a great day.